Good morning, and welcome to your favorite lesson of the year, story problems. I love them just as much as you. But there's some tricks to make them easier. That's what we're going to be working on today, is how do I make story problems a little bit easier, especially when they have algebra involved. All right, so today, all of our equations that we're going to be writing from our story problems are all going to be in slope-intercept form. And the good thing is, again, there are some tricks. All right, first trick is how do we know to use slope-intercept form? Well, here is the reason that we use slope-intercept form. Anytime that the total, the final answer in the end after we've added everything together or subtracted everything or whatever we needed to do, that total answer, if it's a missing number, we use slope-intercept form. If it's a number that we know, we're going to use standard form, and that'll be tomorrow's lesson. All right, so next, we always find the starting value. That's the place we want to begin with slope-intercept form. Where did we start? What was happening at the very beginning of whatever this situation is, and then we're going to be adding something to it or subtracting something with it, and that's going to give us our final answer. But that's the place we start, that y-intercept. I remember graphing, our y-intercept is essentially, again, if you're thinking about most graphs are just the first quadrant. We normally don't show these other quadrants. Again, we normally don't use these quadrants here in most graphs. In the real world, we just look at positive numbers, and then you'd see something happening going up or down, whatever, line graph, whatever it is. Again, that starting value, that would be the place right there where the things begin. All right, so then we want to look for another thing. It's called the rate of change. All right, the rate of change is our slope. And that is, again, something that's changing, and this is the rate. $2 per hour, or, something like that. Usually the word per is involved, but not always. All right, and then the missing number, our x, that is the thing that can change. For example, like how many hours you work in one day, or how many hours you spend studying, or how many slices of pizza you eat, things like that. That can be the change. That's what variable means, something that changes. All right, so let's just look at a couple of examples. All right, it says, a canoe rental service charges a $20 transportation fee and $30 per hour to rent a canoe. Write an equation to show the total cost, that's our y, of renting a canoe for X number of hours, that's our thing that can change. And how would it cost, or how much would it cost to rent a canoe for 3 hours? So again, we don't know the total. Because we do not know the total, we're going to write an equation in y equals mx plus b format, slope-intercept form. All right, so that y part is going to be there. Let's find the b first, the starting point. How much are we paying for this canoe service before we even actually put it in the water? Well, right back here, this $20 transportation fee. I don't know if you know what a transportation fee would be, but again, that's essentially you paying the $20 just for them to put the canoe into the water so that you can use it. They're transporting it down to the water for you. Doesn't matter how long you use it, that service only happens once, happens at the beginning. They're not going to keep taking it down to the water every hour because you're already going to be on the lake. So again, that only is a one-time fee. So that's our starting point. And it was $20. So we're going to have a plus 20 at the back. That's the B number we just found. Now we need to find the M number. That's our rate of change. How fast is something changing? I said earlier, a lot of times it has the word per in it. $30 per hour. Because the hours can change. You can rent the canoe for 1 hour, or 2 hours, or 3 hours, or 27 hours. Whatever you want. But whatever you do, it's $30 times every hour that you have it, plus the $20 fee for them putting the boat down into the water for you. All right, next. Let's find the answer. It says, how much would it cost to rent a canoe for 3 hours? So we know X earlier. It said X was the number of hours. We now know that that's 3, so let's plug in 3 where X is. And this is how we can quickly find out how much it's going to cost to rent something for 3 hours. Well, it'll be $30 an hour, so that's $90 for just the hourly rental, plus that $20 fee for them to put the boat in the water for us, and all of that together would then equal 110. But since it's a word problem, we need to make sure our answer is in words also. So it's not just 110, so it's $110 for 3 hours. Again, we want to add some words in there. Let's try another one. A water tank already has 55 gallons of water when Dexter begins to fill it. The water flows into the tank at 8 gallons per minute. There's that per word. That's key. Find the volume of water in the tank 25 minutes after Dexter begins filling it. So we don't know the end total. So because we don't know the ending total, we're going to use slope-intercept form. We don't know how much it has at the end. All right? So what we do know is where we started. That's easy. That B number. It says it had 55 gallons of water when Dexter began to fill it. So we already know it started at 55. Now, X, that's going to be the amount of water flowing into the tank. And we got that per number, 8 gallons per minute. Oh, X means minutes. So X stands for minutes in this problem. All right, so find the volume of water in the tank 25 minutes after Dexter begins filling it. So again, we got our equation. We had our starting point, 55. We have our rate, that's 8 gallons per minute. Now we have a specific number to plug in, 25 minutes. So 8 gallons a minute times 25 minutes, and then plus 55 that we started with. So 8 times 25, that's going to be 200. That's how much gallons he's put in already. And since it started with 55, that means after 25 minutes, he has 255 gallons. Again, word problem needs at least one word in the answer. Doesn't have to be a lot of words. Doesn't have to be a complete sentence or a paragraph or anything crazy like that. Just at least one word. All right, so all your problems are going to follow this exact same pattern today. Find the starting number, find the rate. That's your two numbers to plug in. Your starting number is always the B, the rate's always the M. And then there'll be a second level question to asking you to plug a number in and find a real answer. All right, good luck today.